Welcome to an introduction to market simulations. My name is Megan Peitz, and I'm the Ingenuity Ambassador here at Sawtooth Software. I'm joined by my colleague Walter Williams. Walt has been with Sawtooth over 15 years and is the product manager of our Choice Simulator tool. He's the one who's created all these exciting features that we're going to show you today. So if you ever have any requests, Walt's your guy. Now let's get started. Okay, so we're here today to talk about an intro to market simulations. We're going to cover the reason for conducting market simulations, as well as our different simulation methods and the search methods offered within our choice simulator. So a bit of background. We like to think of the choice simulator as a choice laboratory for testing a bunch of different marketing strategies or product offerings or service bundles. And the greatest part about the market simulator is that it can reflect real world behavior, right? Because we're getting individual level utilities that convert into these shares of preference that are really actionable and make sense to managers. And they also keep the integrity of the segments that you have in the marketplace as well as the individuals. So you can see a little example on the bottom. We have our three attributes of brand, interest rate, and credit limit, and our three products across the top that we've built. Typically, you can toggle through each of the levels. So in our example, we have a Visa with 15% interest rate and a $2,500 credit limit versus a MasterCard product and a Discover product, each garnering their own set of shares. Now, of course, if maybe MasterCard were our client, right now they have the lowest share. So we might want to recommend maybe lowering their interest rate or increasing their credit limit. And we could toggle those things and dynamically the shares would change and we could see the lift. So you can see how something like this would be incredibly actionable to whomever you're providing these results to. The other piece you have to remember about conjoint data is that examining utilities and importances are only going to get you so far. My favorite saying, and you'll probably hear it more than once in the webinar today, is that lies are in the averages. The default output from a Sawtooth software estimation is to see a summary sheet that basically takes the average of every level of every attribute. But those averages don't tell the whole story. There's this fallacy of division that can take place where you assume that because the whole in the average preferred a specific level, then that means everybody preferred that specific level. But we know that isn't always the case. For example, we have 3 respondents here, and we're asking them about the color, let's say, of a widget that they would prefer to purchase. That color could be blue, red, or yellow. And we estimate their individual level utilities for each of those colors, and we get utilities for respondent 1, respondent 2, and respondent 3. If we were to only look at the averages, we'd take the average of the blue column and get 30, the average of the red column and get 45, and the average of the yellow column and get 35, and we would conclude, well, red has the highest average, therefore our widget should be red. But does any one respondent actually prefer red? No, right? Respondent 1 actually has the highest utility for blue, respondent 2 the highest utility for yellow, and respondent 3 the highest utility for blue. So there's these polarizing colors, half of the group that likes blue and the other half of the group that likes yellow, that makes us come to this wrong conclusion, essentially, if we were to only look at the averages. In addition to the benefits of the simulators, they also help you answer strategic questions. So when your client comes to you asking questions like this should immediately flag that you need to deliver them a simulator, because the simulator will help you answer at which price people are willing to switch to a competitor, or if you could modify your product to reduce cost, would you still be able to maintain the same share of market? Other things like, could you launch a high-end product and a budget model? Or maybe do you only get to have one or the other given your brand's equity? And you can also take a look at if the new product you plan to bring to market will actually cannibalize your own sales or bring share from maybe your competitors. All really awesome questions to deliver. You can also measure competitive effects within the market simulator. So for an example, we're in the market of widgets today, I guess, and we're going to assume that 80% of the market prefers round widgets and 20% prefer square ones. So the question becomes, well, which should we take to market? Now, if you didn't have any other information other than the 80% prefer round and the 20% prefer square, round would be the logical choice, right? Because that's what people prefer. But if there are 10 competitors in the market and they're all only offering the round widgets, you would actually learn from a simulator that you could get all 20% of that share should you just create a square one. But you wouldn't be able to learn that by just looking at the averages. We've got a great new video, and it's super short, up on our website at www.sawtoothsoftware.com/choice-simulator-video. When you get the deck, you can also click on this hyperlink up to the YouTube. But it just talks through the power of a choice simulator in a very kind of marketing-oriented aspect. But we really like it. Okay, so I've hopefully convinced you that simulations are good, but how do we do it? So of course, we need our utilities for our different levels within our different attributes. Ideally, we're going to do this by estimating using hierarchical Bayesian regression so that we get individual level utilities. In the remaining examples, we're going to talk about ice cream at different price points. It's easy, it's simple. We've got 2 flavors, vanilla and chocolate, and we've got 3 different price points. And in this example, we have 500 respondents for whom we each have individual level utilities. So now I'm going to turn it over to my colleague Walt, who's going to talk through the simulation methods.
All right, thank you, Megan. So the simulation method is basically the idea of how do we turn these utilities into shares. So turning the utilities very esoteric, shares very straightforward, and so we want to be able to change those so that people can understand them, especially managers. Now the ways that we simulate depend on the assumptions that we make about how people choose. And so we're going to talk first about the first choice rule, and then we're going to follow that up with what's called the Logit probability. We will refer to it as the share of preference rule. And then we're going to talk about randomized first choice, which is a technique that was developed here at Sawtooth Software. So first choice is very simple, very straightforward, and we're going to assume that respondents choose the product that has the highest utility. And then for each product, we're going to report the percentage of respondents who chose that product as best. So it's very, very simple choosing method. So if we look at an example, in our lovely little ice cream, I'm going to try and simulate 2 different ice cream cones. One might be a 25-cent chocolate, and the second one would be a 35-cent vanilla. Now you can see that for respondent 1, the highest utility is for the chocolate cone, and the same is true for the respondent number 2. They both have a higher utility for chocolate. And so in first choice, we would assume winner takes all. They're going to get 100% of the share and vanilla is going to get 0% of the share. However, if you look at respondent number 500, you can see that the vanilla cone was the preferred one. And so in that case, respondent 500 is going to allocate 100% of their share for the vanilla cone rather than the chocolate. Now, if we kind of look at all of the respondents in the whole, we can kind of see that, hey, 65% of our respondents preferred the 25-cent chocolate cone. So that all 65% had the higher utility for that one, whereas 35% of the respondents chose the vanilla cone. Now, first choice is really easy to understand because it uses a very simple choosing assumption that you're going to choose the highest utility always. And so we throw away some of the data about the other products that are in there. We don't exactly know how similar, or were these 2 very close and chocolate just barely beat out vanilla, or was chocolate so very much more preferred over vanilla? We don't know that anymore. because we basically took that to winner takes all. And so when you're looking at the results of first choice, you're going to see that the standard errors are a little bit higher because we are throwing away a little bit of that information. So when you might want to use the first choice rule, if you have large sample sizes, things that are very stable, it can work quite well. Another situation is, yeah, you look at it and say, is this the kind of thing where it's going to be 100% or nothing? Cars, refrigerators, things that are purchases that don't happen very often, things like that where, yeah, I've got to make one choice right now, and it's got to be one of these. So one of the other assumptions that we're going to make is, the assumption that we make there in first choice is that you're always going to be 100%. But we know that oftentimes that's not the case. Buyers aren't going to be consistently purchasing with 100%. Random things happen, out of stock conditions, things that can influence choice. Variety, sometimes you just want to try something different. And so respondents are usually not 100% always going to choose the same thing, despite what our models might say. And so there are certain ways we can model that. There's the idea that instead of saying that the winner takes all, we could look and say, what is the probability in terms of percentages that a respondent might choose this product? So if we look at this example with products A, B, and C, where in the case that first choice says that B has 100% of the share, perhaps, if we looked at the probability of choice, that the share of preference is what we call it, that the B's probability of choice is really 60% versus C, the next runner up, having 30 and A having 10. So how do we do that? And what we're going to do is we're going to look at the Logit rule. And most of you are probably familiar with the Logit rule. And what we're going to do is we're going to use this lovely kind of, well, I guess we didn't put Greek in it, but that's a good thing. The probability is going to be the exponentiated utility of our product, say alternative A, and we're going to divide that by the exponentiated utility sum of all the products, just like you can see in this formula here. And basically that will give us the probability of choice. So if we look at these three products, A, B, and C, and we're going to have, A has a utility of a total utility. So we looked at all of the attributes that comprise double A, and we summed up the utility for each of those levels. So the product A utility is the sum of all the attribute utilities, all the levels that went into that product. B has a utility of 0, and C has a utility of negative 1.25. Now, as we remember about utilities, that doesn't necessarily mean that C is not a good option either, but we want to translate this into something that can really be easily understood. And so, like, if we were going to do the computing the shares of product A, we're going to take that exponentiation of 0.75, and then we're going to divide it by the exponentiation of all the utilities that we find there. And then that will boil down to the fact that the probability of choice for product A is actually going to be 62.2%.
Now, if you actually came to our 3-day workshop, we would make you do this by hand just to get a feel for how the formula actually works. But the great news is, of course, when you use the choice simulator, all of this is done automatically behind the scenes. But nothing fancy. There's no proprietary formulas going on within Sawtooth software. It's all based on the Logit rule and simple mathematical formulas that have been around for decades. So keep going, Walt. Sorry, I had to jump in there.
No, thank you, Megan. Now, when we deal with share of preference, this introduces a certain problem, which we often call the red bus, blue bus problem. And we like to use that term because the actual term is independence of irrelevant alternatives, or IIA. Now, that states that the ratio between any two alternative shares should be independent of all other alternatives. It implies that there's a constant substitution rate, which is unrealistic. Now, that might be a little bit confusing, so we're going to run you through a little bit of an example. We'll talk about drinks here. Now, what we're going to do is we're going to consider two drink alternatives, Pepsi and milk, and they have utilities of 1 and 2, respectively. So if we were going to look at the shares that were generated for Pepsi, we can go through the equation here, and we can figure out that Pepsi has a 26.9% share, whereas milk has a 73.1% share. Okay, now what we're going to do is we're going to consider that Coke is now going to be in our consideration. It's a product that we're going to consider, and it has a utility like Pepsi of 1. Now, what's going to happen here? Now, we would normally expect that Coke is going to compete with Pepsi, but if we go through and we compute the shares given Coke, we see that Pepsi's share now goes down to 21.2, and Coke's share is equal because it had the same utility, and milk share has gone down to 57.6. And you can see that there is a huge change in the amount of there's a change for both Pepsi and milk, but milk loses a lot of share, and we can see there that the proportional change in that bottom table is the same because Coke is going to steal equally proportionately from the other two, but that really shouldn't have taken much from milk at all. In all reality, we think that Coke should have taken share from Pepsi and really not from milk. So in order to kind of reduce this IIA red bus, blue bus problem, we use latent class or hierarchical Bayes utilities so that we have things at the individual level, and that reduces the amount of, or sorry, it captures as much heterogeneity as possible versus something like an aggregate logistic or Logit run, which would only give us the average utility. But basically, by having individual level modeling, we can reduce that significantly because we're capturing that heterogeneity. However, it can still happen. And so one of the methods that we've developed here at Sawtooth Software over a number of years is called randomized first choice. Now, randomized first choice kind of sits in a middle ground between the first choice and the Logit choice rules, or the share of preference choice rules. And we can use this for aggregate and individual level, although it benefits largely from having individual level utilities. What it's going to do is it's going to assume that you're making multiple choices, and what it's going to do is it's going to split the shares based on multiple trips, that it's going to assume that you're going to make multiple trips and that you're going to be a little bit different, and it's going to simulate kind of an error structure that says that, hey, you know, maybe there's a little bit of error in the way that we've measured the utilities, maybe there's a little bit of error in the way that we've measured the product choices, and so it can be tuned. It basically uses this error structure to account for products that are pretty similar, like Coke and Pepsi, so that in the end it's splitting the shares between Coke and Pepsi and not really between milk, because they're not, because milk is not as similar to Coke and Pepsi. So let's go ahead and look at an example of randomized first choice. So we looked at this before where we had this first choice simulation where, respondent 1 chose chocolate, respondent 2 chose chocolate, respondent 500 chose vanilla. But if we look and we say, hey, what if we actually look at respondent 1? Let's just take him, this person, and look at them specifically for a few minutes. And let's do multiple iterations. And in each iteration, what we're going to do is we're going to take their actual utilities, and then we are going to modify them slightly using error that's determined by how similar it is to other products or other features that are being simulated. And we're going to do this multiple iterations where, like in this first iteration, we say I'm taking the utility and I'm going to add a certain amount of error. And then I'm going to sum up the utilities for the two products. And in this first iteration, number 1, you can still see that chocolate dominates the vanilla cone. And so we're going to take the first choice there, and it's going to be chocolate. Now on another iteration, like iteration 10,000, we might add a little bit of different error. So each iteration, we're going to change the error that we add to the utilities. And in this case, on iteration 10,000, vanilla ends up having a higher total utility. And so the first choice goes to vanilla. And what we're going to do across all these iterations is we have the first choice for each iteration, and then we're going to average those across all the iterations, and then we end up with the shares of preference. And I apologize if this isn't a great example, but what it does a wonderful job of taking that situation where we had Coke and Pepsi, and we look at the similarity between Coke and Pepsi, and we decide, and it figures out that really the Coke drinkers are going to take from the Pepsi shares and not really as much from the milk shares. And so randomized first choice can do a great job on that. Let's go ahead and, so randomized first choice, if it has any weaknesses, one of them is that there are certain attributes like a price that say, hey, you know what, I don't really want to have correlated error. If my price is the same as another product that I'm simulating against, I don't necessarily want the error to be correlated because of similarity, or because that would end up usually rewarding prices that are different and penalizing prices that are similar. So if there's another product that's closely priced to mine, we would actually be penalized in randomized first choice for that, versus the person that maybe even had a higher price but it was significantly different. They would actually kind of get a little bit of a reward in terms of the kind of error terms that we generate for that. But we allow you to turn correction for product similarity off for attributes like price, where that doesn't really make a lot of sense. And so randomized first choice can be very well tuned for that sort of thing. Another one of the weaknesses in randomized first choice is that if you're simulating, say, just a product versus the none, or two products in competition, or say many products, it doesn't always make sense. For the low end, you have things where you're really not, if you're choosing two products against each other or a product against the none, there's not really a lot of product similarity that you need to kind of correct for. On the other end, if you have, say, a lot of products, sometimes you might end up with shares that are so small that you start wondering whether you're getting more error than signal in those. And so while randomized first choice is quite robust, you do want to use it with care and make sure that it really should apply in that situation. And the simulator actually does a good job of actually telling you this might not be the best time to use randomized first choice. So I think from the next part is we're actually going to show you a little bit of the simulator. Now, we can show you slides all day, but it's more fun to look at the simulator itself. So I'm going to show you my screen, and I hope you can see it. Megan, can you see my screen?
Yep, we are good to go.
Thank you. I should have closed that before, but we'll come back to that. I'm going to start back here at the beginning of where we started our simulation methods discussion, and I'm going to show you a little bit about the simulator, and then we're going to go in and talk about a first choice simulation. So when you open up the simulator, now this is available either through Lighthouse Studio, or it's available as a standalone piece of software, and it looks the same, with one small change being in Lighthouse Simulator you don't have the file menu, because obviously within Lighthouse you wouldn't need it there. The basics of the simulator are I can create a scenario, which is basically a set of products that I want to simulate. I can create, duplicate, I can simulate some or all of my scenarios. If I come over here to the utility sets, I can choose the utility run that I want to simulate with. And so if you have multiple sets of utilities, perhaps you've run different HB models on the same data and you want to see how they differ depending on the assumptions you made in the model, you can select the utilities that you would like to simulate with. Here is the attribute info. So if I want to look and say what were the levels of my project, and I can see the different levels for each of the attributes, I can expand and contract them. Now, one of the things you're going to see down here is my price attribute. And there are two checkboxes over here, being is continuous and is price. Now, continuous is basically an accommodation so that it helps in terms of entering in products, but it basically says, hey, this is actually a continuous variable. This is numeric. I expect to be doing things like interpolation on this. And in the case that we do that, we provide this additional value column that you did not see on one of these other attributes that allows you to say, I don't want to have to put in 1, 2, 3, 4, 5 for these values. I want to enter this value here, like 100, into the simulator, so that if I'm trying to do something like 115, the interpolation is natural. It's what your people that are going to use the simulator are going to naturally want to enter. And so we put in these values here that say, hey, this allows us to simplify the way that we enter in our simulation scenarios. The other field you're going to see here is price. And we check this specifically so that if we know this is price, when we come out, we will turn off or alert you that we want to turn off the correlated error in randomized first choice. It also allows us to look at revenue later on when we're doing revenue simulations. Allows us to calculate some of the revenue information from there. Prohibitions is an area where you especially can put in information about what things were prohibited from the design. You may have prohibited a certain brand from occurring with a price that was not going to be available. So if you did not interview respondents with that combination, so that was prohibited from the survey, you should not be simulating on that as well, because we didn't measure that effect. And so we do not want to simulate that. Now, oftentimes that's going to be something where you don't want your client to simulate on that. And what we'll do in Lighthouse Studio is we'll carry forward the prohibitions that were used in the design. And then if you try and do a prohibition, depending on the options that you set, we will either put that as a warning in the report, or I could check and say, I don't want this to be done at all, and you'd actually get an error Instead, I can either determine whether I just want it to be a warning in the report or an error that's generated to say you should not be simulating this combination. On the conditional pricing over here, that's another, during a lot of your surveys, you might have a conditional pricing where the prices that are shown to the respondents in the interview were determined by some of the other levels that were shown in the product or in the scenario or in the tasks. And so we can set up a table. Those are carried forward from Lighthouse, but we can also, in standalone, we can set up that table so that if we have a conditional price, if this price were determined by some of these other attributes, we could actually show the prices here that were valid for the combination there. This area here is the revenues and costs. This allows me to add incremental revenue or incremental pricing depending on certain levels or combinations of levels, assuming that maybe the price that I put into my price column is a base price, and some of the other levels are going to add. Perhaps I have a premium brand that's going to add to the price. I can also determine my cost structure on a level or combination of levels, such that I can then do simulations involving cost or profit. This allows us to do all sorts of things there. Here we have a few options where we can create some reports, so we can look at the average utilities or and look at specific things there and get confidence intervals on our utilities. For simulations that I've done, I might want to create a report for a manager. They might want that, say, in Excel or a PowerPoint. We'll actually create a little bit of a slide deck with some of the results already inserted for you to as a starting point for you. And I can go through and I can look at how much precision I want in the results, if I'm doing revenues, profits, or costs, what should be the currency that I'm using there, at least to show in the display. Now over here, I'm just going to show you that the simulation I'm going to be using is first choice. So this is a scenario, and for the duration of our kind of demos, we're going to assume that we are the Carnival Cruise Line. Welcome, you are now an employee of the Carnival Cruise Line. I apologize if in reality you are working for one of their competitors, but for what we're doing right here, I think we can be a little forgiving. So what we're going to do here is we're going to simulate 4 different cruises out there. They're all 7-day cruises, and we have a couple of different options of where we're going, what cruise line, and again, we are the Carnival. So we're assuming that we have a couple of competitors out there from Holland America and a couple from Royal Caribbean, and we have our pricing over here. And I've already run the simulation, but I'm just going to run it again, just so you can kind of see it goes very fast. And what we have here is, oops, a mistake. I'm going to show you shares of preference first. But here we have share of preference. And if we look and say, which one are people most likely to choose? This is again using the first choice rule. So 47% of our respondents were actually going to choose this East Caribbean from Royal Caribbean, even though it's pretty, it's an expensive option. You can see that we've created some graphs in different styles here for you. Now we look and say, well, this is a first choice simulation. Maybe I'm somewhat interested in knowing exactly which respondents chose which. That option is available here with individual results. So if I turn this option on by clicking it, I can actually rerun my simulation. And in addition, you can kind of see down here in the tabs of this little spreadsheet, that in addition to the the average shares, I also have a tab here where I can look at the individual results. Now, the individual results you can see for this first respondent here, they chose the East Caribbean, this number 3, but you can kind of see, and here you can see that behavior of 100% to the winner and nothing for anybody else. And so all of this information is here. All the respondents that are in this project are available, are going to be here. If I want to save these results out to Excel, I can do that by clicking on this little save icon. Now we want to compare this to our share of preference simulation. And so if I run this share of preference, I'm going to choose this one again because I want to do this in share of preference. So here we have share of preference, and similar to first choice, most of the people again are doing East Caribbean. So that's good. We're agreeing with our first choice, even though we've changed the assumption we make a little bit about how people choose. And just as an example of showing you the differences, I'm going to turn on individual results for this one. And now we can look at these individual results and we can see, oh, for each respondent, instead of being 100% on East Caribbean, he's actually got, maybe up towards 20% of probability of choosing us on our Mexico cruise. And this person here, chose us for the cruise, but in all reality, this one was a close second, really close. This person strongly prefers our lovely cruise to Mexico. And that's information that we didn't have when we were running this with first choice. And the way that I'm going to change it, you can see here if I'm selecting on this one, you can see here the simulation method is first choice. On this one here, I've changed the simulation method. It's simply a drop down to go to share of preference. And next, I'm going to show you, this is randomized first choice. And again, I just chose randomized first choice here from the drop down. And randomized first choice is, I'm just going to do this. All right, that's what I want. So randomized first choice, in this situation, it was a very quick simulation. Because randomized first choice is doing multiple iterations for respondents, it can take significantly longer depending on the data. But in this case, it ran very quickly, and you can see that its shares are very similar to the share of preference shares that we generated. In this case, yeah, East Caribbean still doing really well. And so one of the things that we can do with this is now, given that I have the scenario set up, I can play with it a little bit, and I can say, well, perhaps I want to lower my price a little bit. So maybe I'm going to go to $125 per night. What's that going to do to my share when I'm simulating? So now that I've lowered my price, I'm going to make a copy of this one because I don't want to lose what we had there. So here's our new simulation, and this is our price, our lowered price, and I'm going to turn this one back to 150. But I'm going to show you this one here, and we're going to look at the differences in the share. So I've lowered my price, and I've gained a little bit over 6% share, and I'm taking share from pretty much all the other three, a good amount of share. So you can see that I can play with my pricing here and get a different, and look to see where might a good price be. If I go down to 100, oh, I can go up to 20%, but you know what? I may not be ready to go to $100. That might be just a little too cheap it might be below my cost. Can I look at something in between? Can I I didn't have this as one of my levels, but maybe I want to try $112. Now, like I said before, we set up this one to be continuous so that we can set up interpolation. And this allows us to say, all right, I can interpolate at 112 and it will actually correctly show that this is between that 17 and 20% that I did before. Now, perhaps my costs are actually, I could get by with $90. Can I do $90? And you can actually see here that $90 is actually extrapolated. This is below the first level, which was $100. Now, extrapolation is always dangerous. You should really be careful all the time when considering extrapolation. Randomized first choice will not allow you to do it. First choice and sheriff preference will allow it. They use a straight line projection to do extrapolation, but this is not an area that you measured in the survey, and so you should really be cautious and avoid this at all. At any rate, you should try to avoid this, but because there are situations where you just simply have to do something like that, we do allow the simulation to do that. Unfortunately, it's not available within randomized first choice. So at any rate, the simulator can do both interpolation and extrapolation with a few caveats. And so with that, that's kind of a brief overview of the simulation methods. And I'm going to turn back the time back to Megan for a bit.
Awesome. Thank you, Walt. I appreciate that. Let me know if you can see my screen.
Yes.
Great. Just a quick question before we move on. You mentioned in your first choice slides that once the sample size is large, then you're probably pretty safe using first choice versus share of preference. How large is large, would you say?
I don't have, do you have a good idea on that, Megan? I don't know. I think it really depends on the data, the quality of the data that you get. But if you had, I would say you'd probably want 500 or so respondents to get going on that.
Yeah, so the data that you're looking at here has 600 people in it. And they were pretty close. I usually lean towards like 1,000, but you're totally right. If you have a lot more attributes than we're showing here, or even more levels, you're going to have more error around your estimates and so on and so forth. So typically you could play around with it and see if you can use first choice. But again, try to use the simulation method that reflects what people are doing in the real world. If you have variety seeking behavior within your category, then you should probably be using share of preference. And honestly, share of preference is typically my default. When you export, the choice simulator has a capability to export to an Excel simulator. There is a randomized first choice plugin, but it does not work on a Mac. So just make sure if you are delivering an Excel simulator, you're using share of preference when you're building your simulations. But yeah, I'm typically using share of preference. I love randomized first choice for specific scenarios, but there were its weaknesses. And then first choice, like Walt said, for when you have those one-off kind of decisions, like buying a home, buying a vehicle, buying an appliance. We also had a question about is plus or minus 20% extrapolation acceptable? I would say 0% extrapolation is acceptable. I am a purist at heart, and I think it's really important to have conversations up front around what are the actual levels of price that you are going to want to test. What is the absolute lowest and what is the absolute highest, and then create your levels accordingly, because we can always interpolate between things, but we should really never extrapolate.
Yeah, I would agree with that, because it's an area you didn't measure.
Right.
And so when you try and simulate something into in an area, you just don't know what the error structure looks like because you didn't measure it.
And we actually have a slide right on that. So thanks for the good segue on that, Walt. We don't really know what that relationship looks like. We're making a guess with first choice and share of preference, but it could completely catapult down, right? It could be an exponential curve instead of just a straight line. So just please do your best to never extrapolate. All of the examples that Walt is showing are actually available as sample files within the choice simulator. So you could even download the demo from our website and start playing around or even follow through what we're talking about. We're using the cruise sample data set. So I'm going to talk through a couple of the search methods because if you didn't notice, as Walt was going through things, we kind of had to set up the scenarios, right? We had to say, here's the Carnival Cruise, here's the Royal Caribbean, and so on and so forth. And that answers, how good would our Carnival Cruise product be if we did X, Y, and Z? But a lot of the time, we're more trying to answer questions like, well, which product should be the best? And again, lies are in the averages because if we were to only look at the averages and pick the best levels, that's not necessarily going to be our optimal product. Because one, if we only look at the total utility, we're not going to be accounting for that heterogeneity. And we saw in the cruise sample that there are people who like the Caribbean and there are people who like going to Alaska. Those are two different groups of folks, right? And we don't capture that if we only look at the highest utilities. Looking at average utilities also don't account for costs. So we as a company or a manufacturer or a provider really can't go to market with all of the best features at the exact lowest product or price, I should say. It's usually not feasible. So a lot of the times those highest average utilities are going to build a product that you actually can't take to market. So it's a common approach, and we would recommend that's why you go into the simulator, so you can figure out which product is best based on some of those things you want to search on, like both share and revenue and cost, which Walt's going to show you in another example after we talk through some of these simulation methods, which are going to help us do optimization. So we believe that conjoint simulators are the best for trying to figure out optimization because of the fact that we can build in the current competitive environment. So you saw we built in the 3 other cruise lines, assuming that Carnival is our customer. We're also accounting for respondent heterogeneity because we're typically going to be using individual level utilities, and we can even tune our model and tune the exponent, include availability and external effects. To more accurately project our market choices so we get even closer to what's happening in the real world. Within our choice simulator that Walt's been showing you, we automatically run through thousands of simulations to find what that optimal product or product set is or service bundle. And we can do that optimization on one or any combination of share of preference, of revenue, of profitability, or of cost. And if you do searches on more than one, we call this a multi-objective search. You can also set up filters so that you can kind of limit your search space. So you could say, hey, don't find me products that have a negative profit, or don't find me products that are less than this amount of money. You can also include existing products in your optimization as well. So what we're going to show you next is an example scenario of a product optimization search, where with Carnival as our client, we're searching to try to garner more share. What do we have to do to get people on this Carnival cruise, right? Is it change our destination? Is it increase our number of days? Is it have fancier staterooms available? So we can search through all of the possible combinations of destination, number of days, stateroom, the ship amenities, and the price in competition with our fixed competitors. But you can start to imagine that if you have a lot of attributes, each with a lot of levels, you're going to run into millions and millions of combinations, right? So a 10 attribute, each with 5-level study, has almost 10 million different combinations of products. And then if you're trying to optimize multiple products at the same time, that's a big number, right? So to search through all the possible combinations could take even the fastest computers a really, really long time. So within Sawtooth software, we provide you with 3 search algorithms. The first one being exhaustive. It is exhaustive, right? It goes through every single possible combination. And because it does that, you are guaranteed to find what's called the global optimal solution. So the one that best fits your entire population. And with exhaustive, you can conduct those multiple objective searches where you can search both on share and revenue, let's say. But again, as that search space becomes larger, exhaustive is going to take a long, long time. So what you can do next is the grid search. And grid is what we call a greedy algorithm, in the sense that it's really, really fast. You pick a starting point and it starts to climb up this hill. And as it's climbing and it gets to the peak, if it can no longer get higher, the algorithm stops, okay? So it can go really fast, and it can help you kind of reduce that search domain because it'll give you a good idea as to what the optimal product is. But because it climbs up that one hill and goes as fast as it can, it's not necessarily guaranteed to find that global optimal solution that you would find with exhaustive, because you might have several peaks to your data. So a good visual is this here, where we have our greedy algorithm kind of starting over there on the bottom area and climbing up the hill. And it finds its top spot, and another iteration of the algorithm finds its top spot. But you can see it's missing out on the other hill entirely. And so when your data has more than one peak, for example, if you are in the financial business, or if you even have a credit card in your wallet at the moment, you would be familiar with the example of the people that like to carry a balance on their credit card are probably completely different than the people who don't like to carry a balance and really prefer to use their credit card for all their purchases because they're trying to gain rewards. Okay, these two people are going to be looking for completely different products, and you'll have to do multiple iterations of a grid algorithm to make sure that you get to both of those peaks. So that is one reason why we've implemented, I can't say come up with because it wasn't our original idea, but why we've implemented a genetic algorithm within our software. And genetic is faster than exhaustive, but it's going to be a little bit longer than grid, and we'll talk to you about why. And the really great part is that it's going to find a variety of near optimal solutions. So instead of just that one solution or a couple solutions from grid, it's going to find a couple optimal solutions. And most of the times it does happen that one of those solutions is the most optimal. And you can also conduct those multi-objective searches that you can do in exhaustive as well. You're still not totally guaranteed to find the global optimal solution, but it's less vulnerable to that than the grid search option. So I'm going to let Walt talk through the genetic algorithm, since he was the brains behind putting this into the actual software.
All right, thanks, Megan. The idea of a genetic algorithm comes out of evolutionary biology. This should be the idea of survival of the fittest. So you should be somewhat familiar with this. What we're going to do is we're going to treat each of these things that we're searching on, each attribute that we're searching on is a chromosome, and the value of that is kind of like a gene. And then when we kind of put those all together, like a set of these chromosomes, we're going to consider that to be like an organism. And so we're going to kind of use these terms from genetics. Okay, kind of going on there, what we're going to do, it's a very simple process. We're going to generate a pool of organisms. So we're going to generate a population using random or something else that we call targeted values, and I'll talk about that a little bit. And then what we're going to do is we're just going to check each of these organisms in terms of their fitness. That fitness is going to be utility, share, revenue, and we're going to basically assess all of these products that are in the population, these product combinations. And then we're going to look at all of these combinations, and we're going to say, or these organisms, and we're going to look at their fitness, and we're going to say, you know what, you two are going to have we're going to choose you two to be parents, and you're going to have offspring. So we're going to basically choose parents, and we're going to combine them just like you would in the real world. We're going to evaluate the offspring's fitness, and then finally we're going to have a cataclysmic asteroid hit the population, and it's going to remove all the least fit members. And then basically we start the process over and over again. We have multiple generations of doing this. Let's go ahead and look at the next slide here, where this is where we're going to show you a little bit. So if I have two parents and they have certain attributes with these levels chosen, basically I'm going to use crossover and create an offspring that, for, like, you can see that the first 4 attributes is just, I've randomly selected from one of the two parents which level to put there. But we also, just like in real genetics, we have mutations. So like on attribute 5, neither parent has level 3 for that attribute, but we randomly mutated one of the levels, and so that one's changed. That adds a little bit of variety and allows these things to evolve a little bit. Moving on, so each generation, like I mentioned before, is where we have this population, we evaluate them, we pair them off, we have offspring, and then we cull the population, we kill off the least fit members. We call that a generation. And so basically what happens is we just run generation after generation until we reach the maximum number of generations we asked for, or the population fails to improve. Basically, we identify that the population has basically reached its maximum potential. So I talked a little bit about targeted initial population. I just mentioned that we can start our population with either a random, which means we just select a random set of levels that are within the search space. But what if, we actually could say, well, what if we knew if there were products that were already pretty good in the search space? And so this is thanks to Scott Ferguson at NC State, who's helped us with this research. He's done a lot, or actually it's his research that we're using. And basically what we're going to do is we're going to use a little mini grid search with individual respondents, and we're going to find solutions that are already somewhat good, and we're going to seed the population with those rather than just purely random. And this is really nice because it helps reduce the number of generations that you need in order to finally reach the maximum. So it helps the genetic algorithm run faster. And we've also seen in our testing that it can actually improve the final solution. So you can maybe do more generations and get further along than you could otherwise. So we're going to go back and look at the software now, and I'm going to show you again how the software really works. And I hope you can see my screen there.
Yep.
Okay, what I've done here is I've set up an exhaustive search. And again, we are Carnival. We're kind of looking and saying, well, what would be a really good cruise that we could offer? What's the best cruise that we could offer given our shares, or according to share? And so I can type, instead of just having a single level in here like I have for these other 3 products, I can just type in a little bit of a formula, and we've tried to make this seem easy to do. So if I want to do a formula, I can just start here with the equals, and I can say I want to try levels 1 through 6. This was a 6th level attribute, as you see here. I have 6 different options, so I can say 1 through 6. I want to try all of these. On number of days, I want to try 1 through 5, all of those, and I want to try all the stateroom options. I want to try all the amenities options. On the price, I actually decided I wanted to look at things in $10 increments. What if I want to look at things in $10? And so I actually am going to use this function here, which is called range. And so this is a function that you can use in any of these fields. In fact, this here is just shorthand for the range function. And I'm going to give it the minimum value, the maximum value, and then this is an optional parameter, but I can tell it what's the increment. What do I want to do? I could do pretty much whatever I want here in terms of what are the increments I want to look at. I'm going to do $10 increments. And so what I'm going to do here, and I've set this to be an exhaustive search. So here in this thing, the range behavior. So here's a range, and this is what I want it to do with that range. I want it to search with those ranges. I want them to search exhaustively. And so if I simulate this, you can see that this is going to take it goes fairly quickly depending on what simulation method you use. And it's going to give me a report, and it's going to show me that this top item here has a share of 49.96. And the destination was the East Caribbean. And all the things that were searched on are here in blue, whereas things that were not searched on will show up here as normal text. And you can see it was an 8-day cruise with a balcony, more amenities at $100. So there we go. That shows us this is kind of the best thing that we could offer people. If I wanted to do this as a grid search, I can go over here. You know, this is an example where I've set this to grid. So you see here's the exhaustive search, the grid search, and the genetic search options there. And so this is the same scenario, and I can search on this one, and you can see that, hey, this one actually came up with the same answer as the other one. So it came up with the optimum solution, and it'll show me how did I compare to the other ones. Back here, this is kind of the summary of results. I asked for the top 10, and so here's the summary, but I can look at each one of these individually, and I can say, here's what my competitors were doing when I was searching here, and I can see how their shares change as for each of these searched options. The genetic, this one will run really fast, but it's still, you can kind of see it's going to run through some generations. So it's going to run through about 10 generations before it actually says I couldn't get any farther. And so again, and you can see here that it also found this optimum solution. Now this isn't the best example that we could show you, because in this case we're basically coming up with the best features at the lowest price. Now when you're setting up your situations, they're going to be a bit more realistic and than this one might be. And so you'll actually see where that these do very well in a competitive scenario. This isn't quite the best. I also wanted to show you here that I can actually perhaps share. Yeah, I can get the highest share by lowering my price, but that's going to tank my revenue, as we've already seen. All of these here were showing us that the best prices were at $100. Well, of course they are. But what if I'm actually searching on revenue? I don't want to maximize share. I'm not in business to maximize share. I'm in business to maximize revenue. So what I've done here is I've actually going into the search settings, which this little settings cog here, I can go in there and I can say, I don't want to search based on shares of preference. I want to search based on revenue. So now it's actually going to take that price attribute and it's going to use the price that it finds here, multiply that by the share, which is a percentage, which would give me my revenue. How much do I expect to make, given the people that would choose me? And so if I simulate this one, you can see that my revenue is going to be $55 based on the things that I've chosen. And you can see it's not telling me that $100 is best now. Now it's telling me that this price is the best. And you can actually see there are different prices going through here. This one was actually pretty low price for only a difference of $3 in revenue. So I can look through these results and I can find, oh, you know, maybe this is better, maybe this is better, or any of these. And Megan mentioned very quickly, perhaps I don't want to just search solely based on revenue or share, but actually want to say, I want to find things that are balanced between both of them. So I can actually use both as objectives. And I can do the simulation here. And you see it's just about as fast to do multiple objectives. And it's pulling up some the information here. And you can see that here is kind of this what we call the Pareto curve. I'm not going to go into a lot of detail on that here, but I can see that, you know, in most cases, I'm going to be trading off revenue for share. That seems reasonable. The higher my share, the lower the revenue. The lower my share, the higher the revenue. And I can find items out here that are fairly balanced between the two. Maybe one of these is something that I want to go after. And again, here's all the report information is available for you to look through. In fact, and we can see both the share and the revenue here in the report. With that, I'm going to turn back to Megan just for a bit.
Great, thanks, Walt. And I know we are running out of time, so I just wanted you to know I only have 2 slides left. We just wanted to give some actual recommendations based on these search algorithms. So pretty simple. If your number of attributes and levels is feasible to search, run Exhaustive. You're guaranteed to find the global maximum. You can even output all of the potential solutions instead of just the default is showing the top 10. But when Exhaustive is not feasible, we say start with the grid search and go through multiple passes. You know, click on grid search, click into that gear, maybe up the number of iterations, and just make sure that when you run grid, you're getting the same answer for every iteration. If you do, it's probably likely that it's optimum. If you're not getting the same answer, then take those grid search results and kind of reduce the domain of your search space so that you can rerun Exhaustive. So in the cruise example, if we found that the Eastern Caribbean is always winning in the grid search, but it's just the different combinations of stateroom and price that are kind of varying, then let's force fit our Carnival cruise to go to the Eastern Caribbean, and then let's run the Exhaustive on the remaining attributes, okay, and reduce that search space. From there, we would recommend you use genetic if the response surface is irregular with many peaks. So if you're getting different answers from the grid search, then you might want to use genetic, especially if you don't feel comfortable reducing the domain to run Exhaustive. And if you have multiple objectives, which is a great value add, I feel like, to the client, then you're kind of only in the camp of Exhaustive or genetic so that you can maximize on both profit and share, which is what Walt just showed you. So if you have a suite holder license, you already have access to this module. If you have CBC or the advanced CBC subscription, you have access to the simulator, but you will need the advanced simulation module in order to conduct these optimization searches that we just showed you. So if you're not currently a user, please shoot me an email and we'd be happy to set you up with something. Okay, that is all we have for today. Thank you for joining us, and we hope you have a great rest of your day.